All right, now it's time to get ready to actually graph these functions. So I want to summarize some of the things we're learning and just add a couple more details that are going to help us graph these rational functions. So finding your critical points is going to help. There are a collection of critical points, of course, the y-intercept. Now, like when we've done, oops, I don't want that up yet. When we've done polynomials, quadratics, we found where it crosses the y-axis by setting x equal to 0. Likewise, with the rational functions, if we find where it crosses the x-intercept, we set y equals to 0, and we're going to find our x-intercept points. Now, this does have a shortcut. We can streamline this a little bit, and I'm going to alert you to that in a minute. If we had time, we could discover this in the classroom and kind of discover the shortcut, but I'm going to have to just cut to the chase and tell you how to analyze this a little faster. Another critical point that can come up in some rational functions is a hole. So the graph has a hole in it. And so we'll be looking for that. Now that's kind of rare. I'm not going to really go crazy on those kinds of problems, but the holes happen when you factor it. Now that's important. You're going to hear that word factor. If you factor the numerator and the denominator and it has x minus a in the top and the bottom, a hole is going to show up in the graph. Another thing that's a little bit more advanced, it's not going to come up very often, is occasionally the graph will cross or touch points on the horizontal asymptote. So if we had a horizontal asymptote on this one running right here, it's possible that you can get a graph to come up across the horizontal asymptote and then settle down on it. So they both have tails on the horizontal asymptote, but this one crossed it once. And that's easy to find. It's kind of like finding the x-intercept points. You set it equal to 0. You set y equal to 0 for an x-intercept. Well, for these crosses, you set y equal to the horizontal asymptote value, and it'll tell you that point where it crosses. Now, I suggest that well, hold that thought. I'm going to give you a few more tips here. Then I'll give you my suggestion. So, some shortcuts to this whole process. When you start out with a rational function, if you can, not all of them can factor, but it's a good idea to start. Just factor the top and the bottom, because different information comes from those factors. So, then remember that the horizontal asymptote comes from the dominant division of the leaders. Now, this is that shortcut I was telling you about right here. When you solve the function for 0, the denominator is going to get multiplied out, and it's not going to affect the solution. So the x-intercept points totally involve the top. So if you need an x-intercept point, it's really about solving the top. Vertical asymptotes totally involve the bottom. Now, one more little detail. The tails on the vertical asymptotes. Vertical asymptotes involve the bottom, but there's a tail feature here that I want to briefly illustrate for you. Here's a rational function, and notice the bottom. Okay, so vertical asymptotes, the bottom, we're looking at this. Those linear factors on the bottom are going to tell us our asymptotes. There's an asymptote here and here. Those two values are going to cause zeros, which will make the graph broken, and we'll get different branches. And we see, sure enough, there is an asymptote here at -1. And there's another asymptote here at -2. Okay, so we know that already. That's how we find our vertical asymptotes, by looking at the restricted numbers on the bottom. But there's another pattern I want you to notice. The pattern involves the tails. Here is a pattern on the tails. Notice the tails on the asymptote. One tail goes up to infinity and the other tail goes down to negative infinity. So at the asymptote x equals -1, the tails are opposite. One goes up, one goes down. But notice the tails at x equals 2. On the left side of this asymptote, the tail is down, and on the right side, the tail is down. This one, the tails are the same. So tails are going to be opposite or the same. And sometimes they're opposite in different directions. They go down and then up, or sometimes they go up and then down. Or sometimes they're the same. They're both going down, or sometimes they're both going up. And you can identify that by the degree of the linear factor. Now we're focused on the bottom because that's where vertical asymptotes come. This is degree 1. It's odd, which says the tails are opposite. Are opposite. This one is degree 2. So tails are, I'm not going to have enough space to write that. Tails are the same. So because of that second power, both of these tails went down. Now sometimes you have a second power and both tails go up. And there's other things we're going to have to do to determine their direction, up or down. And that's going to be simple as plugging in a number. Okay, we're going to do several examples now. And I encourage you to go back. Oh no, I have one more slide here. I broke down the steps of graphing. Actually, it's from the book, actually. It gives you a series of steps here, things to work your way through to make sure you're creating a good graph of a rational function. Now, I want you to take these 2 slides and go back and study these. And then when we're doing a problem, go back again and correlate each step from this page and this page. And find how is number 1 on this page connected to this graph we're doing. How is number 5 on this page connected to the graph we're doing? And the same with this. Go through these steps and look at the graph and ask yourself, each of these, how do they correlate? And the more you make those connections, the faster you'll get at graphing. Okay, so the next thing coming up is just a series of examples where we're going to graph rational functions.